Hi, and welcome to day 3 of radicals. Today we are adding and subtracting. There are a few steps that you should have first. Alright, so the steps we need are 1, simplify the radical, and 2, combine like terms. Alright, so the first problem we have there is 3 square root of 7 plus square root of 7 plus 4 square root of 7 plus 8 square root of 7. We treat radicals just like we do variables. If they're like terms, then we can combine them and we only add the coefficients out in front. So this problem here is no different than saying 3x plus x plus 4x plus 8x. And when I do that, I have 3 plus 1 is 4 plus 4 is 8 plus 8 is 16x. So if I go back to the original problem, in place of x, I just put radical 7. So it's 16 radical 7. So I have 3 radical 7s plus 1 radical 7 plus 4 radical 7 plus 8 radical 7. So 3 plus 1 is 4 plus 4 is 8 plus 8 is 16. All right, for number 2, these are cube roots, but they both are a cube root of 2, so we simply just, in this case, subtract because it's minus sign the coefficients. So 5 minus 1 is 4 cube root of 2. For number 3, radical 5 and radical 3 are not like radicals, so it simply stays radical 5 plus radical 3. We cannot combine the terms. For number 4, I have the cube root of 7 minus the square root of 7. Since the roots are not the same, I have the cube root of 7 minus the square root of 7, and they do not get combined. Number 5 is not as simple as number 3 because I can actually simplify the radical first. Radical 48 breaks down to 16 times 3, and radical 12 breaks down to 4 times 3. So square root of 16 is 4, so it's 4 radical 3 plus square root of 4 is 2 radical 3 minus radical 3. Now I have like radicals, so I can simply add and subtract the coefficients. 4 plus 2 is 6 minus 1 is 5 radical 3. For number 6 there, square root of 27 breaks down to, I should say, 3 radical 3 because it's 9 times 3. Six times the square root of 1 radical, or 1 divided by radical 3. Clean up to 6 times 1 over radical 3. And we learned in yesterday's video that you have to rationalize. So you have to multiply both by radical 3. So this is going to become plus 6 radical 3 over 3 plus 50 breaks down to 25 times 2. So that becomes 5 radical 2. And 8 is square root of 4 times 2. So it's minus 2 radical 2. Now, 6 and 3 can reduce, so 3 becomes a 1 and the 6 becomes a 2. So now I have 3 radical 3 plus 2 radical 3's. So I would get 5 radical 3. Plus 5 radical 2 minus 2 radical 2. 5 minus 2 is 3 radical 2's. So that's my final answer there. For number 7, I don't have to simplify 2 radical 5 because it's already simplified. I don't have to do anything with the 9, but 20 breaks down to 4 times 5. So it will be 2 radical 5 plus 9. Square root of 4 is 2, so minus 2, and then the 5 stays under the radical. So I have a positive 2 radical 5 and a negative 2 radical 5, which cancel each other out, so my answer is simply 9. For number 8, my first set of parentheses is already simplified. My second set is not because 8 is 4 times 2. And I have this negative out in front that I must distribute to both sets of parentheses. So I have 6 radical 2 plus 5 minus 11 minus square root of 4 is 2, so it's 2 radical 2. So I have a 6 radical 2 and a negative 2 radical 2, which will give me 4 radical 2. Oh, sorry, my mistake, that should be plus. So 6 plus 2 is 8. 8 radical 2. And 5 minus 11 is negative 6. And we tend to write things with the number first, the whole number first, and then put the radical part second. And that's going to be important. I'm sorry about that. Later on. So all I did was just switch the order. So it's negative 6 plus 8 radical 2. Okay. For number 9, we have some variables involved, and we also have to simplify our radical. 32 is 16 times 2. X cubed is x squared times x. So I will have square root of 16, which is 4, times that 5 that's out in front. So 4 times 5 is 20. Square root of x squared is x, and I'm left with 2x under the radical. Minus 50 breaks down to 25 times 2, and the x cubed breaks down to x squared and x. So the square root of 25 is 5. The square root of x squared is x, and I'm left with 2x underneath the radical. Now you can see that I have like terms in front of the radicals. They both have an x, and underneath my radicals is the same, so I can subtract, and I get 15x radical 2x. For number 10, same concept except for the fact that they're cube roots. So I'm going to break this down here. Oh, sorry about that. And 125 is a perfect cube, and the cube root of 125 is 5. Y squared cannot be broken down because 3 does not divide into it evenly, so it's cube root y squared minus 64 is also a perfect cube, and the cube root of 64 is 4. Y squared can't be broken down here either, so it's still y squared minus the cube root of y cubed can be simplified to just minus y. So I have like terms here because they're both cube root y squared, so 5 minus 4 is 1. So it's just the cube root of y squared minus y for my final answer. Okay, for number 11, I have the cube root of 1/27 minus the square root of 1/3. Because I have fractions, I have to clean this up. Even though they're not like terms right now, we still have to simplify. So this will become 3, oh sorry, that's not a cube root, my mistake. That's just 3 times the square root of 1/27. So it's be 3 times the square root of 1 is 1. The square root of 27 breaks down to 9 times 3, so it becomes 3 radical 3. And here my 3's cancel out, so I'm left with 1 over radical 3. And it's minus, the square root of 1 is 1. Can't take the square root of radical 3. So it's just 1 over radical 3 minus 1 over radical 3. I know we're supposed to rationalize denominators, but in this case I have the same fraction. It's no different than saying 1 minus 1. So this would be equal to 0. If you didn't see that and you wanted to rationalize, it would look like this. So I multiply by radical 3 over radical 3, so it'd be radical 3 over 3 minus, since that's the same thing, radical 3 over 3, which is still 0. Something we need to address is the fact that when you take a square root of something that has a power that happens to be a perfect square, change colors here. So if I'm taking the square root, oh, it didn't change for me. Oh well. The square root of x to the 16th, y to the 9th. I do not ever take the square root of the exponents. If it's an even exponent, I simply take half of the exponent, because this is a square root that's like having a little index of 2. So I just would divide it by 2. Just like when we had the cube root, we divided it by 3. So this becomes x to the 8th. Y to the 9th breaks down to y to the 8th times y. Half of, well, there the color changed. Half of 8 is 4, so it becomes y to the 4th radical y. I noticed on your exit ticket today in class that you wanted to say that that was equivalent to x to the 4th, y to the 3rd. Not so. Okay? This is my answer. So please, please, please be careful of that and make sure you're following those rules.